In this lesson, we'll have a quick overview of some PBR basics. Now, this is not meant to be a technical explanation, but rather a high-level overview for you to get started in doing PBR texturing. For this project, we are using the Metal Rough workflow. So I want to take this time before we begin painting to give those of you who are new to PBR a quick understanding of how the shaders work. Here's a basic shader ball. This is comprised of different channels. These channels are base color, roughness, metallic, normal, and height. So all these channels work together to give the result shown on screen. Now let's go through each of them so we can understand how the values play with one another. First is the base color, which is the easiest to understand. Simply put, it's the color of the material you're applying. So if I change the base color to blue, we end up with a blue sphere. If I change it to red, we'll have a red sphere. Next we have something called the roughness channel. Unlike the base color, the roughness channel is a black and white map containing only grayscale values, where a value of 0 represents black and a value of 1 equals white. Now, to understand roughness, you want to ask yourself, how rough is the surface? When a surface is completely smooth, like a mirror, you'll get a perfect reflection. How this relates in our texture map is a value of 0, or black, meaning the surface is not rough, which will give us a reflection of the environment map. If the surface is extremely rough, you'll get no reflection. When we do this in our texture map, we set it to a value of 1, meaning the surface is rough. And you'll also notice the absence of the highlight. Now the roughness map is not explicit to 0 or 1 values, but all the values in between. Shown here are different roughness values set to the sphere. Starting at the left, this is sitting at 0.25, in the middle, 0.5, on the far right, 0.75. Now the roughness map is where you want to try to tell the story of the asset, as using it creatively can really bring the surface to life as it modulates the light as it hits the surface. Shown here on the left is a shader with a more thought out roughness map, and to the right of it is the actual roughness map itself. You'll notice the light is being broken up by this roughness map. Next is the metallic map. This again is a value or black and white map. Now, if the surface is non-metallic, the value will be set to 0, or black. If it is metallic, the value is set to 1, or white. You can see the surface begins to look more like a metal surface at a value of 1. Now if we add a base color to this, you'll see that the surface that is set to non-metallic, the highlight is the color of the light hitting the surface. When the value is set to metallic, the highlight is actually colored the same as the base color, which is how metals react in the real world. Lastly, we have the normal and height channels. Now we already baked our normal map out, but we can also paint in additional normal map details. What these will do is add the illusion of extruded or inset details onto the mesh. The way these channels work within Painter are essentially the same. We can paint in the normal map or the height map. Either way, once the textures get exported, they'll be computed straight into the normal map. If you'd like to further explore PBR theory, Algorithmic has a 2-part free PBR guide which talks about these principles in detail. I've included these in the project files for you to have a look at. Now that we understand some basic theory behind the shaders, we can begin the next lesson by laying down some materials.